All right, here we go. Oh, sorry about that. All right, so we have the 8.6 notes. We'll say part one for right now. There might be another part to these, might not be. So, um, we'll see. We'll see about that. We'll see how the video goes. So, okay. So now we're moving on to something that we call tricky trinomials. So what we've been doing with 8.5 was we were factoring trinomials that essentially, if you write it out, like, they look something like this, where they had no number out in front of the x squared here. When we have a number out in front of the x squared, say like you put a 3 out in front and everything else was the same, then essentially it turns into what we call a tricky trinomial. Now the great thing with tricky tries, I call them tricky tries, just kind of shorten the name up, is it's not really that different from what we were using when we call it with the long method, all right? So with these ones, we have to use the long method. We can't use the short method at all right? And other than that, the process is basically the same. You want to factor out a GCF if possible. Now, the only other step that people might get a little tripped up is you have to multiply the A and the C together. All right? That's kind of why I was kind of, a lot of people, would probably say, for that, I'll even roll back to some of these examples here. I would say you need to multiply this 1 and then 10. People are like, well, why do we need to do that? It's for this one right here. Once we get to the numbers out here, we always have to multiply the A and the C together. Put that number on the top of your diamond, put a B on the bottom, solve the diamond, and then I'm going to you can just erase this here. And then, basically after that, use what I'll say the long method to factor. Alright? But again, tricky tries, it basically is using that long, this is basically exclusively using that long method. The only thing that's going to change is that it's not just going to be that C value that we put up there. The C value is going to change. A times C, that C value will change. But let's take a look at some here, okay? So you're looking, say, for example, 1 here. 2q squared minus 9q minus 18. Again, you're always looking for a GCF. You look, there isn't none. So now what you're going to do, it's already in standard form. So we're going to set up our little diamond here. Negative 18 times 2, that gets me negative 36. Instead of just putting the negative 18, I'm going to put these two numbers, A times C, multiply them together. Negative 9 stays on the bottom. That doesn't change, okay? All right. So now I want two numbers that'll multiply to negative 36 and add to negative 9. If you think about that, you'll get... it's going to be, I think, 12 and 3. I think it's going to be negative 12, positive 3, all right? Because negative 12 times 3 is negative 36. Negative 12 plus 3 is negative 9. So now what we're going to do, we're going to go down here. Using the long method, I'm going to rewrite my expression, 9q minus 18. I'm going to bring down the 2q squared. I'm going to bring down the negative 18. And I'm going to split apart the negative 9 as negative 12q plus 3q. All right? And again, the order in which you put these does not matter. Group them up, factor by grouping, when you're using the long method. Take out of this first one, take out a 2q. You're left with q minus 6. Negative 12 divided by 2 is negative 6. Out of this one, 3 and negative 18. GCF of that one. Only take out a positive 3. 3 divided by 3 is 1. Take a q out, that's q. Negative 18 divided by 3 is negative 6. I have the same thing in my parentheses here. So I'm just going to combine the 2q plus 3. And then the q minus 6. And that's it right there. That's it. All right. Going on to example 2 here. All right. Now I'm going to do there's a bit of a typo here. This should be z squared and this should just be z. So just kind of disregard that. For negative 22 and then 30. If you look, you can technically take a GCF out of those. Take a 2 out. You're left with 2z squared minus 11z plus 15. All right. Well, we still have this 2 out front here, so I can't really use the short method at all. but it made my numbers smaller, you know? I mean, if anything, you take a GCF out, you want to make these numbers smaller, all right? Because, you know, you'd be working with 4 times, that's 120, and then negative 22, that you're dealing with larger numbers. These make them smaller, you know, more numbers that we can, you know, kind of deal with. So now what I'm going to do, I'm just going to worry about this one inside here. This 2, I'm going to put a little triangle around it. That just kind of hangs out there. I don't really worry about it until the end. So I'm going to do 2 times 15, all right? That gets me 30. That goes on the top of my diamond. Negative 11 goes right there. 2 numbers that multiply to 30 and add to negative 11. Positive on top, negative on bottom. I know these are going to be 2 negative numbers. And let's see, 5 and 3, no. 3 and 10, no. 6 and 5. It's going to be negative 6 and negative 5, because negative 6 times 5 is 30. Negative 6 and plus negative 5 is going to be negative 11. I'm going to bring this down here. Just the inside, not the original, but the inside. 2z squared minus 11z plus 15. I'm going to bring down 2z squared, the plus 15. I'm going to split apart the negative 11z as minus 6z, and then minus 5z, all right? And we split these apart, factor by grouping. I can take a 2z out of this first one, take 2z out of this one. I'm left with z. Negative 6 divided by 2 is negative 3. This one, first number is negative, so I'm automatically taking a negative out. 5 and 15, divide both those by 5. I'm left with positive 1z, or just z. Positive 15 divided by negative 5 is negative 3, okay? Now from here, I have the same thing in my parentheses. I'm going to combine the 2z and the minus 5 into one thing, so you get 2z minus 5, and you get z minus 3. To take one of those, put them there. And that's it. Nope, hold up. Don't forget this like I always keep doing. Once you write these final factors out, you got to take your GCF number. You just got to write it out front there. All right, that's basically it. Don't forget that GCF number out front. All right, it's very easy to forget about that because, well, you've seen me do it a couple times already. Okay. All righty. So if you need to pause, write anything more down, you can do that. I'm going to erase the ink in 3, 2, 1. Boom. And let's go ahead and work example 3 out here. All right. I'll do it in purple. Okay. Let's see. I'm already in standard form, n squared, n, and 7. So now what I'm going to do is set up my diamond. 2 times 7, that gets me 14. Negative 11, that goes on the bottom there. Okay? I want numbers that'll multiply to 14 and add to negative 11. Well, it's positive, so hold up. So this one's going to be positive. This is negative, so you know that these are both going to be negatives. And, well, let's think about it. Maybe if we need to, we can even write it out here. 14. 1 and 14. 2 and 7. 3 doesn't work. 4 doesn't work. 5 doesn't work. 6 doesn't work. 7, so we're back to it. 1 and 14. That doesn't add up to 11. 2 and 7 won't add or subtract to 11. Oh, shoot, none of these work. All right? If they don't all work, just make sure you write yourself out prime. All right? So again, that's going to happen, all right? You're going to kind of hit the wall there where, well, 14, nothing really, well, these numbers that multiply to 14, none of them add to 11, or none of them subtract to 11. That happens. That just means the expression itself is prime, okay? And that'll go ahead and wrap it up for the 8.6 notes. So as you see, again, using as long as you're using the long method, it's very similar to the methods that we kind of use in the previous previous videos. Again, it's all fairly similar stuff to what we've been doing. Okay, so those have been the 8.6 notes. Thank you guys so much for watching, and be on the lookout for more videos. Take it easy.